Hello ladies and gentlemen, today we're going to be starting a new topic, and that new topic is called scientific notation. So make sure you write your objective down in your spiral. It says, I will be able to translate a number that is in scientific notation to standard notation. Okay, so there's going to be some vocabulary we have to learn. We have to learn what is scientific notation and what is standard notation. And of course we have to learn the steps that are going to get us from scientific to standard. So first let's talk about what is standard decimal notation. Your standard decimal notation is just the normal way we write a number. It says a number written without exponents. So for instance, if I had the number 1,340, that is written in standard decimal notation. Or if I had the number 0.03. Again, both those numbers, they do not have exponents in them. They're written in the standard way. Okay? So a number written without exponents is called standard decimal notation. Now, unfortunately, sometimes writing a number in standard decimal notation is not always the most convenient. So this right here is written in green. You do not have to write this, but let me just explain to you what I mean by convenient. If you had to express the number of stars in the universe, then you would have to write that number like this, okay? I see a 5 and I see a 0 and then I see a whole ton more zeros behind it. That is how many stars are in the universe. Now think, if you're a scientist and you have to write that number of stars down several times to do your calculations, that is going to be a lot of writing. Okay, so that's not a very convenient way to express the number of stars in the universe. A more convenient way would be to write that number like this. Okay, look at the size difference here. Believe it or not, this value here in green is equivalent to this value here. So one way is written in standard decimal notation, and one way is written in scientific. So you decide which would be easier if you were a scientist. Which way would you prefer? The standard way or the scientific way? Okay? Before we begin, before I start showing you what scientific is, I want to go over some things that you should already know. Again, you do not have to write this. This slide is in green. But when you multiply a number by 10, I want you to think what happens for just a second. So if I were to multiply 5 times 10, most of you should know that that's going to be 50. I want you to think about what happened. You had a decimal right here in front of the 5. You multiplied by 10 and it scooted one place to the right and it made 50. What if I had 5 times 100? Well, that would get you 500. So what happened there is your decimal scooted 2 places to the right. Okay, so you should start to notice a pattern. When there was 1 0, it scooted 1 place to the right. When there was 2 zeros, it scooted 2 places to the right. Okay, another way I could express both of these numbers, instead of 10, I could express that as 10 to the first. And instead of 100, I could have expressed that as 10 to the second power. Let me write that. So if you think about it, our exponent told us the number of times our decimal scooted to the right. So if I had 5 times 10 to the third, my decimal would move 3 times to the right. Guys, this only works with powers of 10, okay? So that's going to be important when we talk about a number written in scientific notation. It's always going to be a power of 10. Okay, so let's go back to the notes. What does scientific notation mean? What it's going to look like a product of a factor A and a power of 10 with an exponent that is an integer. You should be writing this part down. Okay, so what scientific notation is going to look like, you are going to have a number, and it says down here, that number has to be greater than 1 and less than 10. So you're going to have a number multiplied by 10 to a power. And remember, it's always going to be a power of 10. Now this power has to be an integer, okay? This first number does not have to be an integer, but our power has to be an integer. Okay, so make sure you write this down. This is just going through what a number in scientific notation is going to look like. You're going to have a number times 10 to a power. Okay, so pause right here. Make sure you get this written down. Okay, so let's talk about what's going to happen when we change from a number that's written in scientific to a standard number. Okay, this is our first part of scientific notation. So I'm going to have you start with numbers that look like this, and you have to change them to a standard number. Okay, so how are these steps? What are these steps going to look like? Your first step is you're going to be identifying if you'll be moving the decimal left or right. Okay, if you have a positive power here, your decimal is going to move to the right. However, if you have a negative power, let me give you another example. If you have a negative power here, your decimal point is going to move left. So be very careful. Positive moves your decimal to the right, negative to the left. Next, you're going to scoot the decimal and you're going to show your trail. Remember, the number is going to be how many times it scoots. So this one would scoot right 8 places. This one would scoot left 8 places. You're going to rewrite the number with the appropriate commas, and that's going to be your last step. Please, if your number is large, you want to have the commas. That's going to help the reader be able to read that number better. Okay, let's do some examples. Please pause if you need to get these steps written down. Okay, so example 1. This number is written in scientific notation. Okay, again, I can tell because I have a number times a power of 10. So this power is going to tell me how many places to scoot my decimal point. I'm going to scoot my decimal point 5 times. And since this is a positive 5, I'm going to scoot it 5 places to the right. So I'm going to show my trail. 1, 2, 3, 4, 5. If I've got an extra couple of holes here at the end, then I'm going to fill those in with zeros. Now, please do not box this up and say, this is my answer. That's very messy. Rewrite it with the appropriate number of commas. Okay, so starting from the back, coming in 3, there's my comma. So my answer is 248,300. All I did was move my decimal point 5 places to the right. Okay guys, we're going to go ahead and move on. Okay, example 2, 5.95 times 10 to the negative 7. Again, we have a number in scientific. We're going to change to standard decimal notation. Now this exponent is going to tell us the direction we're going to move and how many times. Since this is a negative, we're going to move left 7 places. 1, 2, 3, 4, 5, 6, 7. Almost ran out of room. And remember, all these little loop-de-loops, they don't have a number inside of them. I'm going to fill those in with zeros. Okay, now please rewrite this so it doesn't look so messy. I have 0.12345 and then 595. And that is my final answer. So here we have a number in standard, and then here above was the number in scientific. In this case, I think it was much easier to have it written in scientific. So that was a whole bunch of zeros there. Okay, so these are on your own examples. You're going to take both of these numbers, change them into standard decimal notation.